This week we're going to be talking about Unit 9, Lesson 2, Finding Volume of a Rectangular Prism. The first thing I want to point your attention to is your math chart that is in Google Classroom. You can see the volume formula for a rectangular prism is volume equals base area of the base times the height. As you can see, this is a capital B where all of these here were lowercase. They represented base. This is a capital B that represents area of the base. When we're talking about rectangular prisms, we're talking about these really cool three-dimensional shapes. When we're talking about finding the volume, we're trying to find how many cubes could fill the shape. Whenever we see this capital B, which represents area of the base, you're thinking about the area of the base of this shape. Now, in order for us to find the area of that base, which it is a rectangle, we would find length times width, which is what we talked about last week, finding the area, and then we would just include times the height. So this is a formula you may be used to seeing, volume equals length times width times height. You can use either one. As you move through geometry, you'll be seeing this one, and I wanted you to be sure you understand the capital B means area of the base. So when we talk about finding the volume, we're going to be multiplying the length times the width times the height. So this is our length, this is our width, and this is our height. Of course, this is the length, this is the length, this is the length, the width, and the height. If your shape is drawn to scale, unlike this one, they'll all be the same measurements. So you're measuring these three numbers. Now we're going to do some examples. The first one is this one. Now, anytime we're trying to find the volume of a figure, we want to start with our formula. Volume equals area of the base times height. We can rewrite that to say length times width times height. So this is my length, 5 inches, times my width of 2 inches, times my height of 4 inches. So I'm going to multiply these together. So 5 times 2 is 10, times 4 is 40. And the volume is going to be 40 cubic inches. If you'll remember, we talked about, when we talked about exponents, we said cubed was the same as using this 3. Cubic units, this is where that comes from. We're multiplying the inches, that's our variable, 3 times, and so we have inch to the 3rd power. All right, now one thing that your Apex lesson talks about is that if you are using measurements that have fractions, like maybe these, that it mentions the half units. All right, so you will see some questions where it says, find the volume and then find the number of half units. And so in this case, to find the volume, you would still use that same formula. All right, so we have our length, width, height. Now we want to go on and change that to a decimal, 3 5/10. Okay, let me rewrite that. 3 5/10 times width times height. All right, so you can multiply these in any order that you want to. 3 1/2 times 1 times 6. Is going to give us 21. And since these measures were in meters, we'll say cubic meters. So our volume is equal to 21 cubic meters. If we were trying to find how many half units were in this, we know, based on what the lesson told us, that there are 8 half units in every cube. And so there's a real good video in your Apex lesson, but we know that if we're talking about these cubic units and these fill the shape, we know that each of these cubic units is equal to 8 half units. So if you find this volume and you want to know how many half units are represented, you would just take this, 21, and you would say, multiply that by 8, because there's 8 half units in each. There are 168 half units. So some of your quiz questions will be asking you for both. It'll be asking for just the volume, but then it will also be asking about those half units. So if you know that 1 cubic unit is equal to 8 half units, you would take your volume, because those are your cubic units, and multiply by 8 to get the number of half units. These are both ways to represent the volume. All right, one last thing on your quiz. We have there's a word problem on that last question. This one says, David has a sandbox that is 2.5 feet long, 2 feet wide, and ½ foot deep. How many cubic feet of sand does he need to fill the sandbox completely? So if we're trying to find the cubic feet, that's a keyword that tells us we're looking for the volume, and we're filling something, that's another keyword for volume. It might be helpful to draw a quick little diagram. While this might be a weird shaped sandbox, it's the easiest. It's still a rectangular prism because we've been given the length, the width, and the depth. So even if it doesn't look like a sandbox, that's okay. It's just serving its purpose as a model. So we have 2.5 feet long. We have 2 feet wide. And I should probably go there. And then 1/2 foot deep. So to find our volume, the area of the base times the height, length times width times height. Your length is 2.5 feet times your width times your height. So we're taking all 3 of the measurements that we got from the problem and we're multiplying them together. All right, so we have 5½ times 2. Okay, remember that's going to be 1 times 2.5. Your volume is 2.5, and since we're talking about feet, this was feet times feet times feet. That will be 2.5 cubic feet. So how many cubic feet of sand does he need to fill it completely? 2.5 cubic feet. Remember that when you're working on your quiz in Apex to get these papers back out, that you took notes on. Pull that study guide out that you took notes on while you were working on the study section. Make sure you've worked on the practice section first. Take your time, write your work on a piece of paper. Trying to keep it in your head is going to be hard to keep it